Question 7 of Check Your Skills asks you to determine the general solution. This is a nice one. I can do this rule. Normally when I see a sine and a cos on each side, I want to divide by a cos, but I need to first check that the angles are the same. And in this case, yay, the angles are the same. So we just divide by a cos 2 theta on each side, and we get cos 2 theta, and we end up getting tan 2 theta is equal to 1. And when we've got that, we want to arc tan to get our reference angle. And our reference angle when we arc tan is equal to 45 degrees. I'm just going to show you how to do that quickly. So I have tan, I've taken it across, which means it becomes an arc tan. So shift tan, I'm looking for that -1, that arc tan, and it is equal to 1. I can close the bracket, or I don't have to close the bracket, and I get a 45 degrees. Okay? Now, according to my general solution, when I'm doing this, because I'm doing general solutions, I now have 2 theta is equal to 45 degrees plus k times 180, because that's my general solution for a tan. But now I want to know what theta is, so I divide everybody by 2. 45 gives me 22.5 degrees plus k times 100 and not 180, it's so used to doing that, k times 90. So every cycle, wherever k, a cycle on a k, if you put a 1 in there, it's going to be 90, you're going to add it. So every 90 cycle, I'm going to find out that theta exists at that point. Okay, that's my general solution for that one. Let's try number B. Now this is a clear example where my thetas or my angles are not the same. So here I've got a double theta, there I've got a single theta. My angles are not the same, therefore I'm not allowed to divide by a cos. So I want to then simplify this using our ratios that we understand, or our identities. We know this becomes 2 sine theta times cos theta is equal to 2 cos theta. And now what I can do is I can simplify and divide by my cos thetas. So if I divide this by a cos theta, and I divide this side by a cos theta, I end up cancelling that and cancelling that, and I'm left with 2 sine theta is equal to 2. If I want to divide by a 2, I want to bring this theta over here. We end up having sine theta is equal to 1. And I need to find out what's the reference angle for sine theta is equal to 1 is equal to. So my reference angle, let's go find our calculator. Let's clear it. And we're going to go arc sine, so shift sine 1. And that is equal to 90 degrees. You should already know that. And if you don't, it's okay. Your calculator's there to help you. So this ends up giving you theta is equal to 90 plus k times 360. That's the one. And remember, sine has got 2 is equal to theta is equal to 180 minus your reference angle plus k times 360. So over here, this simplifies now to 90 plus k times 360, which is exactly what I got on this side. So for every 360 degree cycle, you end up getting theta is equal to 90, or whatever multiple of that is for 360 added to 90. Okay, I hope that made a little bit of sense. And then we're going on to C. Okay, so number C, 7C tells me 3 sine theta minus cos 2 theta is equal to 1. And here we can see we've got a lovely identity. I'm going to try and get rid of it so that I could probably factorize this just with sines. So I'm probably going to use this identity, and let's see if it's going to work. Okay, if that doesn't work, we'll have to make it a little bit more challenging and then change the 1 to this identity and maybe try get rid of it with this identity. But let's rather just deal with this as a sine. So we end up having 3 sine theta minus 1 minus 2 sine squared theta is equal to 1. We distribute that negative in, we end up getting 3 sine theta minus 1 plus 2 sine squared theta is equal to 1. We bring this 1 across, it becomes a minus, and then I arrange this in descending order of powers. We have 2 sine squared theta plus 3 sine theta minus 2, all equal to 0. Now I've got a trinomial over here, which means I can factorize, and remember we've got trig factorization, so leave really big brackets. The factors of your first, 2 sine theta times sine theta are the only factors that I can end up doing for my first. Factors of my last is 2 and 1. Let me write that out. So we end up having 2 and 1 as the factors of my last. And it's a negative, which means I'm going to have a plus and a minus. I'm going to have a different sign in each bracket. I need a plus 3. So if I times this 2 with this 1, I'm going to get 2. And I'm going to times this sign with the 2. I'm going to get 2 sine. And I'm going to add them together or minus, and they're going to cancel each other out. So that's not going to work. I need to get a 4. Right? So I'm going to times this 2 with that 2. And if I put that 2 over there and I make it a positive, this mouthpiece ends up giving me 4 sine theta. And then I'm going to take the other term that I've got, and it's a minus, and I'm going to put it in there. This nose piece gives me a minus sine theta. And a minus sine theta plus 4 sine theta does give me my 3 sine theta. So there's my bracket at the end of the day. I'm just going to erase that so that I can actually write, because I'm running out of space. But do pause it and do copy it down. That is brain work. We don't necessarily mark that part. But now I've got 2 identities here. I have 2 sine theta minus 1, which equals to 0. And I've got sine theta plus 2 is equal to 0. That's a 0, not a theta. Okay? So I want to get theta by itself. I'm going to take the minus 1 across, and I'm going to divide by 2. So I'm left with sine theta is equal to a half. And on this side, I'm left with sine theta is equal to minus 2. Now, this is not applicable. I'm going to show you why. You guys have drawn your sine graph. You know that when you draw your sine graph, let's draw the graph in red. It goes up through 0, and it goes down, and it goes up, right? That's your sine graph. What I want you to understand is that this sine graph does not go sine x or sine theta or sine y, does not go beyond 1 or minus 1. So now it's telling me that sine theta is equal to minus 2. It can't be minus 2. It doesn't get there. It stays between 1 and minus 1. Therefore, minus 2 is not a valid solution. And you can plug that in and you can arc sine that and get your angle. You're not going to get, it's going to give you an error. And this is why. And here we end up having sine theta is equal to a half. So I want to know what my reference angle is, RA is, when I arc my sine. So let's go clear this, and we're going to go arc sine, which is shift sine. and it becomes a half. So you can write it in exactly like that, or you can write it as 0.5, and you can close the bracket and you can push equals, and you end up getting 30 degrees. So we end up having 30 degrees. My reference angle is 30 degrees, but I know that my general solution for sine, there's two of them. The one is 30 degrees plus k times 360, and the other one is theta is equal to 180 minus 30 plus k times 360 degrees. And that ends up giving you 150 degrees plus k times 360. So I've got two general solutions that satisfy this, 30 plus k times 360, or 150 plus k times 360. And that is you determining the general solution for this item. I hope you guys know how to determine the general solution, how to change ratios, identities with these double angles and even a compound angle, and then carry on and solve for theta. This is you actually solving for x. It just becomes a little complicated because that plus k times 360, but it's a very simple rule, okay? Find your reference angle, plug it in, and see where it exists. So if we had to try and understand this, let's look at this quick sticks. If we had to try and understand this, I've told you that my reference angle is 30 degrees. 30 degrees, we know that this point over here is 90 degrees, and that is where it is equal to 1. We know that 30 degrees is over there, and that's 60 degrees. So that ends up looking at this point. Let's make it a different, let's make it a green. So that looks at this point. I want to know where this solution will satisfy my answers for angles. And if I draw a line, that is what it's asking me. What is this degree? What is that degree? What is this degree? What is that degree? What is that degree that will satisfy this equation every single time? Every single time I do that equation, I will know that whatever this degree is over here will be calculated from this. So this ends up being 30, and then add another 360 to it. This obviously becomes 390. That's on this guy over here. If this one becomes a 1, becomes 360 plus 30, that ends up becoming 390. And over here, if I look at this one, this angle over here must therefore be 150. And if I want to revert back, if I want to minus it, I'm going to times this with a minus 1. That becomes minus 360. Add 50, ends up giving me whatever this angle is over here. Okay, so play around with this, understand how this works. I have taught this to you. I have shown this to you before in class. And that's what you're trying to find out. Where am I going to satisfy this equation whenever it exists on this Cartesian coordinate? Okay, have a lovely day. We're going to move on to question 8.